How many 3-digit numbers are there for which the product of their digits is more than 2 but less than 7? More than 2 could be 3, 4, 5, 6. Product is 3. 1 into 3 is 3. So it has to be 113. So 113 could be 131, 311. 3 can be written as only 1 into 3. Straight away we can do this. 115, 151, 511. These two are prime numbers. They can only be written as 1 into themselves. Of course, 4 and 6 can be written in other ways. But let's start with this. 114, 141, 411. 116, 161, 611. So far so good. 4 can also be written as 2 into 2. So put 2 2's and a 1. Here 1, 2, 2 and 3 variants happen. 3 more here. 6 can be written as 2 into 3, apart from 1 into 6 of course. So this is 1 into 2 into 3. This will have 6 variants. So for prime numbers we don't need to worry, only 3 variants. For composite numbers, those 3 variants will exist, and then we need to look beyond. And so in how many 3-digit numbers are there? There will be 3 here, 3, 3, 3, 12, plus 3, 15, plus 6, 21. 21 3-digit numbers there for whom product of the digits will be more than 2 but less than 7. F of 5 plus x equal to f of 5 minus x for every real value of x. F of x equal to 0 has 4 distinct real roots. Then the sum of these roots is a wonderful question. So I tried some algebraic methods of solving it and then went nowhere with it. And f of 5 plus x equals f of 5 minus x. And so think about this. We draw the graph. F of 5 plus x is equal to f of 5 minus x. So f of 6 is f of 4. So you have 6 and 4. F of 7 is equal to f of 3. 7 and 3. If f of 6 were here, f of 4 would be here. If of 7 were here, f of 3 would be here. Whatever value in between, it will be like that. So some curve like this, some curve like this, some curve like this. It's going to be a graph. You can imagine a graph like that. And so I just want to dwell on this. I tried this, but then it didn't take me anywhere. It looks like it is symmetric around 5. Yeah, so what? And it has 4 distinct real roots. So let's break this framework. Let's assume that it cuts somewhere here and then cuts somewhere here. 2 roots. Therefore, it will cut here and cut here. 4 roots. Now we are on to something. There are 4 roots. Think about it. If f of 12 were 0, assume that 12 is a root. That means f of 5 plus 7 is a root. That means f of 5 minus 7 should also be a root. F of minus 2 should be a root. From 5, if you move some number of units to get a root, you should move the same number of units this side to get another root. Now we are on to something. So navigating from 5, this side if there is a root, that side there is a root. Maybe you navigate 7, maybe you navigate 12, maybe you navigate 15. Forget that. Idea here, suppose this and this are roots. If you add these two, they'll be of the form 5 plus k and 5 minus k. 5 plus k plus 5 minus k is 10. Roots come in pairs. Sum of any one pair is 10. There are 4 roots, 2 pairs, 20. The roots have to be of the form 5 plus k and 5 minus k. They have to come in pairs. 5 plus k plus 5 minus k is 10. 2 such pairs, 20. We invested 10,000 at 5% simple interest, and after exactly 2 years, Joy invested 8,000 at 10% simple annual interest. How many years after Viru's investment will their balances, that is principal plus accumulated interest, be equal? Let's assume it will be equal after n years. After n years, Viru would have 10,000 plus 10,000 into 5 by 100 into n. Joy would have 8,000 plus 8,000 into 10 by 100 into n minus 2. Why? Because Joy is investing it for 2 years lesser. That's it. Solve this, we should get. And 5 by 100, 100 gets cancelled. This is 500 and 100 gets cancelled. This is 800 and minus 1600. 800 into minus 2. This is equal to this. 10,000, this side is also 2,000 plus 500 n is 800 n minus 1,600. Bring this 1,600 this here. 3,600 is equal to 300 n. 800 minus 500. Mark off 2 zeros. 36 by 3. N is 36 by 3, 12. Viru invests for 12 years. Joy invests for 10. Their balances would be same. The train traveled at 1/3 of its usual speed and hence reached the destination 30 minutes after the scheduled time. Oh, wonderful. Speed instead of x becomes x by 3. That means time taken, t, would become 3t. A very simple question. This 3t is 30 minutes after the scheduled time. So the extra 2t is 30 minutes. Or t is 15 minutes. Or when the train travels at x, it takes 15 minutes. When it travels at x by 3, it takes 45 minutes. On its return journey, the train initially traveled at its usual speed for 5 minutes. Lovely. So we're talking about the return journey. So it goes like this. Return journey is like this. On its usual speed for 5 minutes. Usual speed, it would have covered the whole distance in 15 minutes. So for 5 minutes, coming back like this, 1/3 of the distance would have been covered. But then stop for 4 minutes for an emergency. So stops for 4 minutes. 4 minutes get lost here. And so 9 minutes are down so far. The percentage by which the train must now increase its usual speed so as to reach the destination on scheduled time is nearest to 5 plus 4, 9 minutes are gone. The total time taken, the scheduled time, which is 15 minutes. So the train should cover this distance in 6 minutes. If this 4 minutes break had not been there, it would have covered in 10 minutes. Lovely question. So what it would have covered in 10, now it should cover in 6. This speed were x. This speed has to be x into 10 by 6 or x into 5 by 3. If the time taken should reduce, speed should increase. And it's the same ratio. 10 falls to 6, x should increase to x into 10 by 6, x into 5 by 3. X goes to 5 by 3x, an increase of 2/3 of x or 67%. It's a beautiful question because we're just thinking in terms of ratios and you're through. You don't need to do distance by time of speed, speed into time of distance, none of that. Just think in terms of ratios, you're good to go. Log 5 to the base 4 equals log y to the base 4 times log root 5 to the base 6. Take this side, we are through. Log 5 to the base 4 by log y to the base 4. This is nothing but log 5 to the base y. This is log root 5 to the base 6. Let's call this as k. 6 power k is root 5. Y power k is 5. Square this. 6 power k is root 5. 6 power k whole square is 5. Y power k is 5, which is nothing but 6 power k the whole square. Or this is 36 power k is 5, which is nothing but y power k or y equals 36. Log root 5 to the base 6 is same as log 5 to the base 36. The number of real valued solutions to the equation 2 power x plus 2 power minus x is 2 minus x minus 2 whole square. Beautiful question. You think about this. 2 power x and 2 power minus x are both positive. Fine. The minimum value this can take, this is of the form y plus 1 by y. The minimum value it can take is greater than or equal to 2. If it were negative, it will be less than or equal to minus 2. If it is positive, it is greater than or equal to 2. So this side is greater than or equal to 2. This side, this is greater than or equal to 0, or this part is less than or equal to 2. From 2, you're subtracting a non-negative number. The maximum value the expression can be is 2. We're done. This has to be greater than or equal to 2. That has to be less than or equal to 2. The only possibility is if both are equal to 2. Be equal to 2 when x is 0. Put x equal to 0. 2 power 0 plus 2 power minus 0. This is 2. But if you put x equal to 2 here, we get 2 minus, x equal to 0 here. 2 minus 2 square. 2 minus 4 equal to minus 2. It doesn't work. This will go to 0 when x is 2. At that time, it is not 0. So there's no case where this is equal to 2 and this is equal to 2, or we'll have 0 real valued solutions to this. A straight road connects points A and B. Car 1 travels from A to B and car 2 travels from B to A, both leaving at the same time. After meeting each other, they take 45 minutes and 20 minutes respectively to complete their journeys. Wonderful. It's a standard template. You've seen this template. It's appeared many times. C1 this way, C2 this way. And so after meeting, they take 45 and 20 minutes. So they meet somewhere here. So, and then C1 takes 45 minutes. C2 takes 20 minutes. Let's assume C1 has taken t minutes and C2 should have taken the same t minutes because they meet. Okay. Now, their speeds are constant. So the ratio of their speeds will be the same. The ratio of time taken should be same. If C1 takes t minutes and C2 takes 20 minutes, or C1 takes 45 minutes, C2 takes t minutes, this by this should be equal to this by this. The distances are not the same. The ratio of time taken to cover the same distance will be the same. Traveling this time by this time should be equal to this time by this time. T by 20 equals 45 by t, or t square equals 900. T is 30. In other words, C1 takes 50% more time in both instances. Right? C1 takes 50% more time. That means C1 is slower. And so if C2 took time t, C1 will take time 3 by 2t. C2's speed were x, C1 speed will be 2 by 3x. 2/3 of x is 60 kilometers per hour. X is 60 into 3 by 2, 90 kilometers per hour. This template you should have seen before. If you know that template, then this question becomes a complete walk. This is where practice helps. Doing tons of questions, you're likely to hit upon many templates. So make sure you do those tons of questions. A, B, and C are positive integers such that sum of A and the mean of B and C is 5. A plus B plus C by 2 is 5. The sum of B and the mean of A and C, A plus C by 2, is 7. The sum of A and B is, okay, let's multiply this by 2. 2A plus B plus C is 10. 2B plus A plus C is 14. Lovely. I want to find A plus B. If we add these two, we'll get 3A plus 3B plus 2C. I don't want that. If you subtract one from the other, C will disappear. Subtract the right way. Subtract this from this. I don't want negative numbers. B minus A is 4. This is tricky. We're not going anywhere with B minus A. B minus A is 4. How does that help? We want A plus B. Okay, let's do this. B is A plus 4. So plug that in here. So 2A plus A plus 4 plus C is 10. 3A plus C is 6. Lovely. This is where this 3 positive integers part comes in. I tried this question originally and did not accept that. And I was trying to algebraically solve it. 3 positive integers 3a plus c is 6. So the minimum value a, b, c could be is 1. We put a as 1, c is 3. Put a as 2, c is 0. That's not possible. We put a as anything more than 2, c will have to be negative. Or a has to be 1. That means b has to be 5. C has to be 3. We've got all three numbers. The sum of a and b, 1 plus 5 is 6. That positive integers term is given in order for us to crack this funda. Then don't do this algebraically. Think about it. Pause and then figure it out. X equals 4096 to the power 7 plus 4 root 3. Which of the following equals 64? Now there's a bunch of things where being numerically comfortable is very helpful. 64 square is 4096. This is 2 power 6. This is 2 power 12. That is helpful. So the square root idea involved here somewhere. And so x can be written as 64 square whole power 7 plus 4 root 3. Wonderful. So that could be helpful. Fine. The second thing, which of the following equals 64? So we still don't know how to get to 64 from here. And so we can say square root of x is 64 to the power 7 plus 4 root 3. Or square root of x to the power 1 by 7 plus 4 root 3 is 64. 1 by 7 plus 4 root 3. 7 plus 4 root 3 is a beautiful number. 7 plus 4 root 3 into 7 minus 4 root 3 is 7 square 49 minus 16 into 3 48, which is 1. The reciprocal of 7 plus 4 root 3 is 7 minus 4 root 3. Or square root of x to the power 7 minus 4 root 3 is 64. How do we get there? Okay, this is x power 7 by 2 by x power 4 by 3. This is x power 7 by 2 minus 4 by root 3. Sorry, it should be 4 root 3. It's given incorrect. It should be 4 root 3. No, 4 by root 3. 4 by root 3. That doesn't work. 4 by root 3. It's tough to reconcile. This is x power 7 minus 4 root 3. This is also incorrect. It should be square root of x power 7 minus 4 root 3. This is x power 7 by 2 minus 2 root 3. Yep. This is x power 1 by 2 whole power 7 minus 4 root 3. This choice works brilliantly. Choice A, if it had been 4 root 3, we would have exploded. It is 4 by root 3. So we don't have to worry about it. Choice C takes us to 7 x power 7 by 2 minus 2 root 3, or x power half whole power 7 minus 4 root 3. Numerical friendliness, being friendly with picking that 7 plus 4 root 3 and 7 minus 4 root 3 are reciprocals. 4096 is 64 square. That really pays off. So it's a cruel question if you can't pick that. The mean of all 4-digit even natural numbers of the form a+b+b, where a is greater than 0. I spent a long time doing this. Luckily for me, I did not find any of these answers in the first 3 iterations. So therefore I had to find the right answer. So it's an even number of the form a+b+b. So b has to be even. So b has to be 0, 0, 2, 2, 4, 4, 6, 6, 8, 8. A need not be even. A is greater than 0. 1, 1, 0, 0, 2, 2, 0, 0, 3, 3, 0, 0, all the way till 9, 9, 0, 0. Likewise 1, 1, 2, 2, 3, 3, all the way till 9, 9, and so on. So 9 numbers here, 9 here, 9 here, 9 here, 9 here. There are totally 45 numbers. If we add all of this up, then we should get somewhere with that. How do we add all of this up? So think about this. 11 plus 12 plus 33 plus 44 plus 55 plus 99, 9900. We can add all of those up. That's common across the board. So how do we do this? We have 1100 plus 2200 all the way till 9900. The whole thing into 5. Plus 0 into 9, 22 into 9, 44 into 9, 66 into 9, 88 into 9. This is the sum total of everything that we are looking for. We need to divide this by 45. We are through. So let's simplify this. 5 into hundreds times 11 plus 22 plus 33 all the way till 99 plus 9 times 22 plus 44 plus 66 plus 88 divided by 45. Let's take the numerator. 5 into 100 into 11 into 1 plus 2 plus 3 plus till 9, which is 9 into 10 by 2 plus 9 into 9 into 22 into 1 plus 2 plus 3 plus 4 divided by 45. 10 by 2 is 5, 9 into 5 is 45. This is 9 into 22 into 10. 9 into 5 is 45. So make it 2, this 45 disappears. So we have 5 into 11, 55 into 100 plus 22 into 2, 5500 plus 44, 5544. Lovely. Maybe there's a more elegant method of doing this. I don't know that. So, elegant method, what might it be? It's possible. The average of all of this is 5500. Average of all of this is 5522. 5522. 5544. 5566. 5588. Equal weightage. Average of all of this is 5544. Of course, some beautiful elegant method. Average of all this. Average by columns. Get those averages. Average by the row. Get that average. Midpoint, midpoint, midpoint. Life is through. Beautiful method. Feeling bad that I didn't think about it. X plus 1 by x the whole square minus 3 times x plus 1 by x plus 2 equal to 0. Simple. Let's say x plus 1 by x equal to y. Y square minus 3y plus 2 equal to 0. Remember, y is greater than or equal to 2 or y is less than or equal to minus 2. Anything of the form x plus 1 by x, you should know this again. This is y minus 1 into y minus 2 equals 0. Y is 1 or 2. Y cannot be 1. X plus 1 by x cannot be 1. So y has to be 2. X plus 1 by x equal to 2 has x plus 1 by x equal to 2 has only one solution, x equal to 1, or this has one real solution. A person spent 50,000 to purchase a desktop computer and a laptop computer. 50k, a desktop and a laptop. He sold the desktop at a 20% profit and the laptop at a 20% loss. 0.2D minus 0.1L. Overall, he made a 2% profit. Then the purchase price in rupees of the desktop is super. 0.2D minus 0.1L is 2% of 50k. 2 by 100, so it will go away. 2 into 500,000. 0.2D minus 0.1L is 1000, or 2D minus L is 10,000. We know D plus L is 50,000. The total price. Add these two. 3 times desktop is 60,000. Or cost of desktop is 60,000 by 3, which is 20,000. Lovely. Among 100 students, X1 have birthdays in January, X2 have birthdays in February, and so on. X0 equal to maximum of X1, X2, X3 till X12. Then the smallest value possible of X0. So all 100 could have birthdays on January. So X0 could be 100. Technically speaking, X0 could be 90. X0 could be 50. 50 people in January, others being distributed. We want to find the smallest possible. X0 cannot be 3. Because if X0 were 3, X1 to X12, all of them being 3 also, will get a total only to 36. X0 will be lesser, and the numbers are as close to each other as possible. 100 by 12 is 8 point something. So you can have a bunch of 8s. 8, 8, 8, 8. 12 8s take us to 96. You can have 8, 8, 8, 8, 8, 8, 8, 8. 8 8s take us to 64. 9999. That will take us to 100. Smallest possible value of x naught is 9. Everything cannot be 8. But if you have a bunch of 8s and a few 9s, this total can be achieved. In which case x naught will be 9. Two persons are walking beside a railway track at respective speeds of 2 and 4 kilometers per hour in the same direction. So a railway track. A is going at 2 kilometers per hour. B is going at 4 kilometers per hour. A train came from behind them and crossed them in 90 and 100 seconds respectively. Train crosses them. That means the length of the train is crossed. Relative to the train speed is t. Relative speeds are t minus 2 and t minus 4. T minus 2 and t minus 4 crossed in 90 and 100 seconds. T minus 2 is a faster vehicle, traveled in 90 seconds and 100 seconds. Wonderful. So the ratio of the speed should be the opposite of ratio of the times, or time taken into speed is constant. T minus 2 into 90 is t minus 4 into 100. T is the speed of the train. Sorry, I should pick a different variable. 90 minus 18 is 10t minus 40, or t is 22. The train is traveling at a speed of 22 kilometers per hour. Lovely. This is 20 kilometers per hour. This is 18 kilometers per hour. Lovely. Now the train alone travels. So traveling at 20 kilometers per hour, the train takes 90 seconds. Traveling at 22 kilometers per hour, how much time will the train take? 90 into 20 by 22. Make it 11, make it 10. 900 by 11. You go 8 times 20, 81 point some large number, 82's work. X square minus 7x plus 11 whole part x square minus 13x plus 42 is 1. Sounds like an incredibly tough question. But think about this. Any number par 0 is 11. So this could go to 0. Fine. If you have a number 1.6 over anything apart from 0, it cannot be 1, because if it's 1.6 per positive number, it will keep going higher and higher. Negative number will keep going less than 1. It can be equal to 1 only if it were 0, or the only time a non-zero power can give us 1 is 1 power something is 1. It's very simple. So x square minus 13x plus 42 equal to 0, or x square minus 7x plus 11 equal to 1. Solve these two, you're good to go. X minus 6 into x minus 7 is 0, 6 or 7. We need to substitute that to verify, but in both cases it's going to be some integer. We can even say it will be a positive integer. So 36 minus 42 plus 11, yeah, positive. Nothing to worry. Substituting works. Or here we have x square minus 7x plus 10 equal to 0. X minus 2 into x minus 5 equal to 0. X is 2 or 5. You put 2 or 5. You put 2. 2 square minus 26 plus 42. Again, nice positive integer. Nothing to worry. You put 5. Also will get a positive integer. Nothing to worry. 2, 5, 6, 7. All of these work. 4 values. Hang on. There's one thing we have missed completely. We can even get 1 as minus 1 per an even number will give us 1. We'll have to verify that. How do you verify that? X square minus 7x plus 11 equals minus 1. X square minus 7x plus 12 equal to 0. X minus 3 into x minus 4 is 0. X could be 3 or 4. Minus 3 power, if you put x as 3, minus 1 power some number could be 1 if that power is even. So put x is 3, 9 minus 39 plus 42. 9 minus 39 is minus 30 plus 42. This is 12. So x equal to 3 works. Put x equal to 4. That will definitely work. 16 minus 13 into 4 52 plus 42. 16 minus 10, this is 6. That's also an even number. We get minus 1 power 6. So 3, 4 could work as well. So 2 and 5 could work, 6 and 7 could work, 3 and 4 could work, or there are 6 possible values. I missed this one and I got 4 because I completely forgot the minus 1 power 4 thing. So beautiful question. You'll have to worry about this going to 0, this going to plus 1, this going to minus 1 in the time when this is an even number. The area of the region satisfying the inequalities mod x minus y less than or equal to 1, y greater than or equal to 0, y less than or equal to 1 is beautiful. Let's draw this one. Y greater than or equal to 0. This is this. Y less than or equal to 1. Y equal to 1 is this region. We're talking about this band. Mod x minus y less than or equal to 1. Okay, mod x minus y equal to 1. Or y equals mod x minus 1. Now, y equal to mod x is a curve like this. Mod x minus 1 will be a curve like this. Shift it down by 1. So this is 0, 0. This is x-axis. This is a line y equal to 0. This is a line y equal to 1. We're talking about this band here. On top of, inside that band sits this y equal to mod x minus 1 line. So this point will be minus 1, 0, minus 1. Put x equal to 0, y will be minus 1. This point, when will y be 0? When x is 1, 1, 0, or x is minus 1, minus 1, 0. When will y be 1? So 1 equals mod x minus 1. Mod x should be 2, 2, 0, or minus 2, 0. Or this distance is 4. This distance is 2. We're talking about a trapezium of height 1 and sides, parallel sides 4 and 2. Half into 4 plus 2 into 1. Half of 6, 3 square units. A solid right circular cone of height 27 centimeters. Height 27 centimeters. Is cut into 2 pieces along a plane parallel to its base at a height of 18 centimeters from the base. At a height of 18 centimeters, we cut it off. The difference in volume of the 2 pieces is 225 cubic centimeters. The volume in cubic centimeters of the original cone. So this is 9. Remember, if the height is 9, the radius we can find. The height is 1/3 of this height. Radius will also be 1/3 of this radius. Similar triangles. Height is 1/3 and radius is 1/3. Volume will become 1/27th because pi r square height thrice over. It's like length, width and height, 3 dimensions. So if this volume, this tiny cone's volume, where V, large cone's volume would be 27V. This first term's value will therefore be 26V. The difference in volume of the 2 pieces is 225C. 26V minus V is 225 cubic centimeters. The volume in cubic centimeters of the original cone, that is 27V. What is that? 25V is 225. What is 27V? This is 9. V is 9. 27 into 9, the power of 3, 243. A circle is inscribed in a rhombus with diagonals 12 and 16. Diagonals 12 and 16. Nice little rhombus here. Diagonals of a rhombus are perpendicular bisectors of each other. So it will be 6, 8, 8, 6, 10, 10, 10, 10. A circle is inscribed inside this. Beautiful. Beautiful. So we want to find the ratio of area of circle to the area of the rhombus. Area of rhombus is very simple. Half into 6 into 8. 6 into 4, which is 24 square units in the bag. If we find area of the circle, we're through. If we find radius of the circle, we're through. Brilliant. How do we find that? Beautiful. How do we find that? Think about this. I spent a long time thinking about it. Very good question. Radius will be perpendicular to the side of the rhombus. Why so? Because tangent is perpendicular to radius. The side of the rhombus is a tangent to the circle. Right. So if we find radius, we are through. So I'm going to take one of these beautiful triangles carved out by half a diagonal and half a diagonal. This is 8. This is 6. This is 90 degrees. Drop this altitude. We are told that this is h. You can use the idea of similar triangles and get there. Or you can say, we can substitute areas are equal. Half into 8 into 6 is half into 10 into height. Area is base into height, half into base into height. Whether you take this as base, this as height, or this as base, this as height, area should be same. The half gets knocked off. Height is 48 by 10 or 24 by 5. The height of that right angle triangle is nothing but the radius. Or area of this circle is pi r square height. So it is pi 24 by 5 into 24 by 5. That is the area divided by 24. Area of the rhombus. Half into 6 into 8. Area of circle to area of the rhombus. Area of the rhombus. Okay. Area of the rhombus is not half into 6 into 8. It is half into 12 into 16. 96. I made a mistake there, which is why I was worried none of the choices are matching. Thankfully, the choices are available for this one. It is 96 and not 24. I took half of the diagonal. It should be half into d1 into d2. I did half into d1 by 2 into d2 by 2. Right, so this is pi into 24 into 24 by 25 into 96. 24 by 96 is 1 by 4. 24 by 4 is 6. 6 pi by 25. Lovely. My original answer would have given us 24 pi by 25, which luckily enough was not there in the choices. It's half into product of diagonals, not half into product of half the diagonals. Leaving home at the same time, Amal reaches office at 10:15 if he travels at 8 kilometers per hour, and at 9:40 if he travels at 15 kilometers per hour. Forget the starting time. He travels at 8 kilometers per hour and he travels at 15 kilometers per hour. The ratio of the time taken should be 15:8. If he takes 15 t time, he'll take 8 t time. Brilliant. With this, you're through. That means the difference in time taken is 70. He starts at 10:15. He starts at 9:40. Reaches office at 10:15. Reaches office at 10:15. Reaches at 9:40. If he travels at 15 kilometers per hour, the difference between these two times is 35 minutes. 70 is 35. T is 5. This is 40 minutes. This is 75 minutes. We're done. So he will reach in 40 minutes if he travels at 15 kilometers per hour. In 75 minutes if he travels at 8 kilometers per hour. The difference between those two is 35 minutes. Or he takes 40 minutes if he reaches at 9:40 a.m. He starts at 9 a.m. Leaving home at 9:10 a.m. at what speed in kilometers per hour must he travel so as to reach office exactly at 10 a.m. Or he should take 50 minutes. Okay. If he travels at 15 kilometers per hour, he takes 40 minutes. If he has to take 50 minutes, what speed should he travel? 15 into 40 by 50. Take more time, will take lesser. 15 by 5 is 3. 3 into 4, 12 kilometers per hour. Remember, I'm not converting this to hour. I'm not finding the distance. I'm just saying speed into time is speed into time. Find a lot of these speed time distance questions, especially in this format, become much simpler if you can just think in terms of ratios. Ratio of time speeds is 8:15. Ratio of time taken will be 15:8. That's all. The moment you grab that, the starting time is known. You know his starting time is 9. He takes 40 minutes at 15 kilometers per hour. He has to take 50 minutes. what speed should he be traveling at? 12 kilometers per hour. AB is 432, BC is 96. A into B is 432, B into 6, C is 96. They're positive integers, C less than 9. Product is involved. So as much as possible, keep the numbers as low as possible or as close to each other as possible. C is less than 9, C could be 8, 12 into 8 works. 432 is 216 into 2, 2 cube into 3 cube into 2. This is 2 power 4 into 3 cube. Keeping it in terms of prime factorization could be easier. C could be 8, B could be 12. Keep it close. C could be 6, B could be 16. 4 won't work. 5 won't work. 4 into 24. 3 into 32. 2 into 48. 1 into 96 I think is outlandish. Even this we don't need to worry about. It's one of these 4. And whichever one works. So if B were, let's say B is 12, B is 16, B is 24, B is 32. B cannot even be 32, that is 2 power 5, only 2 power 4 into 3 cube. A, what should A be? B is 2 square into 3. A should be 2 square into 3 square, remaining 36. B is 16, A is 27. B is 24, 2 cube into 3. 2 into 3 square, A should be 18. Lovely. So we have A, B, C. A could be 36, B could be 12, C could be 8. This looks nice. Or A is 27, B is 16, C is 6. B is 24, A is 18, C is B being, A is 18, B is 24, C is 4. One of these is the answer. This is minus 9 plus 4 minus 2. So this is better. Just comparing. Minus 9 plus 8 minus 2. This will be better. 27 plus 16 plus 16 plus 6 is 22. 22 plus 27 is 49. 28 plus 18 is 46. 46 is better.
Let's look at this one. If y is a negative number such that 2 power y square log 5 to the base 3 equal to 5 power log 3 to the base 2. And so very often in these kind of log questions where an exponent is there and log is there, a simple trick in the book is take log on both sides. That might simplify something. And so I'm going to try to do that. Take log on both sides and we'll try to do this. So this becomes y square log 5 to the base 3 times log 2 is equal to log 3 to the base 2 times log 5. This is 5 power log 3 to the base 2. So this will be log 3 to the base 2 times log 5. Log 5 to the base 3 here and a log 5 here. So we can choose the base to be 3. It's in our hands. We can choose any base. If we do that, then this log 5 to the base 3, this log 5 to the base 3, these two get cancelled. So we have y square here equal to log 3 to the base 2 by log 2 to the base 3. Log 2 to the base 3 is 1 by log 3 to the base 2. So this is nothing but y square equals log 3 to the base 2 whole square. Or y should be log 3 to the base 2. But the problem here is we know y is negative. It's been given very clearly that y is negative. So y is not log 3 to the base 2. It is log 3 to the base 2 times minus 1. It's minus of log 3 to the base 2. Log 3 to the base 2 and minus of log 3 to the base 2 is nothing but log 1 by 3 to the base 2. 2 power something is 3. 2 power minus of something, minus of the same thing will be 1 by 3. So minus log 3 to the base 2 is nothing but log 1 by 3 to the base 2. We're looking for a choice that says that. It's just this. Beautiful question. Nice, wonderful, challenging question. What you're looking for here when you're combining exponents and log, that first step of unlocking, that is take log on both sides. That's a beautiful trick. So keep that in mind. The moment you take log on both sides and you're plugging that in, now the second trick is there is a log 5 to the base 3 here. We can choose any base. choose the base to be 3. That means you put a base 3 here and a base 3 here. These two get cancelled, knocked off. After this, log 3 to the base 2 and log 2 to the base 3 are just reciprocals of each other. Final thing, when you come here, you have to keep in mind that the question clearly states that y is a negative number. That's something to keep in mind. So the answer is log 1 by 3 to the base 2. On a rectangular metal sheet of area 135 square inches, a circle is painted such that the circle touches two opposite sides. If the area of the sheet left unpainted is 2/3 of the painted area, then the perimeter of the rectangle. I'm going to draw the first diagram here. And so there is a breadth, there is a length to this. A circle is painted such that the circle touches two opposite sides. Obviously, it will be this. Right? If the area, the circle is painted, area of the sheet left unpainted is 2/3 area of the painted area. That is, this area is 3, this area is 2. Right? Quite simply, we need to find a link between the radius and the length. And so, how do we do that? Let's assume a radius of this circle r. Okay. B is 2r. L is 135 by 2r. Area is 135 square inches. And so, this area is 3. The overall area is 5. So, we can find area of the painted region. This is 135 into 3 by 5. So 135 into 3 by 5 is pi r square. We figure that out, we are through. So 135 into 3 by 5 equals pi r square. This is 135 by 5 is 27. 27 into 3 is 81. 81 by pi equals r square, or r is 9 by root pi. We want to find a perimeter of the rectangle, then the breadth is 18 by root pi, it is twice our radius. The length is 135 by 18 by root pi. 135 is a multiple of 9, it becomes 15. This is 2. It is 15 root pi by 2. Looking at 2 times length plus breadth, so twice of length is 15 root pi plus 36 by root pi. Looking for a choice that is 15 root pi plus 36 by root pi. Let us see whether that works out. We're taking a root pi out common. We can take a 3 out common. So we take a 3 root pi out common. There will be 5 left here plus 12 by pi. Yep. Luckily enough, we have a choice that matches. 3 root pi into 5 plus 12 by 5. And very interesting question, but no rocket science here. The key thing, this is 2/3 of this. Or if this is 3, this is 2. The moment you write the ratio down like that, we know area of circle is 3/5 area of the rectangle. Rectangle area is 135. 3/5 of that is 81. From that we get the radius. Twice of radius is breadth. 135 by breadth is length, and then add up and manipulate root pi and the rest of it. Fine. Lovely question, but not too difficult. Let's look at this one. This again with the percentages. Should be interesting. In a group of people, 28% of the members are young while the rest are old. 65% of the members are literate and 25% of the literates are young. The percentage of old people among the illiterate is nearest to. Let's look at this one. It should be simple. 28% are young, rest are old. So 28% young, old is 72%. The standard template, 65% are literates. So literates 65%. So 35% are not literate. And 25% of the literates are young. So 25% of these are young. 25% of 65, half of 65 is 32.5. Half of that is 16.25% are young. Then the percentage of old people among the illiterates is nearest to. So we want to find among the illiterates what percentage, what number is old. We find that, then we can do that by that and then simplify. Out of 65%, 16.25% are young. The remaining are old. Okay. So we can find the old here, plonk that here, find the not literate and then simplify there. Or conversely, we can say among the young people, 16.25% are literate. 16.25. So not literate would be the remaining. 28 minus 16 is 12. This is 11.75. So out of 28%, 16.25% are literate, 11.75 are not literate. This is the young population. So this is 11.75. The remaining is here. 35 minus 12 is 23. This will be 23.25%. So what percentage of this number is this number? That's our question. So we're looking for 23.25 divided by 35 into 100. So I'm going to do multiply by 4, the numerator and denominator, because I don't want to deal with 0.25. 23.25 into 4 is 92. 93 by 140 into 100. So 930 by 14, whatever that is, it is 66. I will take a guess at 66. 930 by 14 should be 66 point something. That's the answer we're looking for. Standard question, the same data set broken in two ways, young and old, literate and illiterate. And then if you're given what percentage of literate are young or what percentage of old people are illiterate, you can fill pretty much everything else. This is a standard template. You should get plenty of practice on this template. Wonderful. We're going to start doing this one. An alloy is prepared by mixing three metals A, B and C in the proportion 3:4:7 by volume. Weights of the same volume of the metals A, B and C are in the ratio of 5:2:6. In 130 kilogram, etc., etc. We'll come to the question part later. There are three metals A, B and C. This has volume in the ratio 3:4:7. So if you have 14 liters, then there are 3 liters of this, 4 liters of this and 7 liters of that. For the same volume, that is, if you have 1 liter of A, 1 liter of B and 1 liter of C, then the weights are in the ratio of 5:2:6. So for 1 liter, you can say it's 5 kilograms, 2 kilograms, 6 kilograms. Why am I saying that? Because the link between these two just jumps out. The ratio of volumes is this. Ratio of weights for unit volume is 5:2:6. For 1 liter of A, that weighs 5 kilograms. 3 liters will weigh 3 into 5. 1 liter of B weighs 2 kilograms, 4 liters will weigh 4 into 2. So the ratio by weight is going to be 15:8:42. With that, we're pretty much done. And so the ratio by weight is 15:8:42. The question here is 130 kilograms of the alloy. The weight in kilogram of the metal C is, so 15:8:42. Add all three up. This is 65 units. So 65 units corresponds to 130 kilograms. This is lovely into 2. 42 units should correspond to 84 kilograms. Luckily, the numbers just fall in place. 65 units is 130. So 42 units will be 84 kilograms. A gentleman decided to treat a few children in the following manner. He gives half of his total stock of toffees and 1 extra to the first child, and then half of the remaining stock along with 1 extra to the second, and continues giving away in this fashion. His total stock exhausts after he takes care of 5 children. How many toffees were there in a stock? Lovely. Let's assume he starts with n. Then he gives away n by 2 plus 1. Or what will he have? He'll have n by 2 minus 1. And then of this, he gives away half plus 1. Half of n by 2 minus 1 plus 1 he gives away. Or half of n by 2 minus 1 minus 1 he'll retain. Straight away we can sense there'll be an n by 4 term sitting here. And then there'll be an n by 8 minus 1 by 4, something like that. Right? So n by 16, that becomes complicated. Right? These kind of questions, one very simple rule, don't start from the first child till the end. Start from right to left. Right? What am I going to do? We know that the last child gets half plus 1 extra. And at that time, he runs out. And I'm going to think about the fifth kid. Think about what does he have with him when he goes to the fifth kid. He gives away half plus 1. So before he gives away the last one, he's given away half of what he had. That means that half of what he had should be equal to this one. Or when he goes to the fifth kid, he should have had 2. Half of 2 is 1, plus 1 is 2, he goes to 0. So when he goes to the fifth kid, he has 2 chocolates with him. Now let's go one more step back. He's given a half of what he had and 1 more. after which he is left with 2. So before giving that one more, he should have had 3. That is half of what he had. Or before he goes to the 4th kid, he should have had 6 chocolates. Half of 6 is 3, plus 1 is 4. He gives away 4, he has 2 remaining. Now we know the mechanism. 2 plus 1 into 3. 0 plus 1 into 2. 6 plus 1 into 3, that is 14. Sorry, into 2. 6 plus 1, 7 into 2. Half of what he had plus 1, so minus 1. So we're doing it the other way around. To 6 add 1, 7 into 2 is 14. To 14 add 1 into 2 is 30. To 30 add 1 into 2 is 62. He has 62 to begin with. He gives away 32 for the first kid. He has 30 remaining. He gives away 16 for the second kid, has 14 remaining. Gives away 8, has 6 remaining. Gives away 4, has 2 remaining. Gives away the 2. Or he should have started with 62 toffees. And so these kind of questions become very simple if you start from the last step backwards. He finally runs out of toffees after he has given to the 5th kid. So think about how much he had when he is going to the 5th kid, and then just work backwards. Once you know the mechanics, it is plus 1 into 2, plus 1 into 2, plus 1 into 2. You can do any math after that. Wonderful. Let's do this one. A solution of volume 40 liters has dye and water in the proportion 2:3. Water is added to the solution to change this proportion to 2:5. If 1/4 of this diluted solution is taken out, how many liters of dye must be added to the remaining solution to bring the proportion back to 2:3? It looks like there's lots of data here, but it's a sitter. It's a proper sitter. And let's go step by step. 40 liters dye and water. So I'm going to write down 40 dye, water. In the ratio 2:3, 2/5 of this, 3/5 of this, 16 and 24. Water is added to the solution to change this proportion to 2:5. So we're adding water. So water will change, but the dye remains as 16. This ratio is 2:5. 2 into 8 is 16. 5 into 8 is 40. So this should be 40. Lovely. If 1/4 of this diluted solution is taken out, 1/4 of the overall solution is taken out. That means 1/4 of this will get taken out. 1/4 of this will get taken out. So finally, we'll have 12 liters of this, 30 liters of this. 1/4 of 40 is 10. 1/4 of 16 is 4. That gets taken out. So we have 60, 12 and 30 now. Now, how many liters of dye must be added to the remaining solution to bring the proportion back to 2:3? What should we add here? So the ratio remains as 2:3. This is going to stay as 30. This should be 2:3. If this is 30, this should be 20. This is 20, we're adding 8 liters. We're not doing anything algebraic, not plonking in a lot of formulae. One very simple, very important idea when you're going from one mixture to another, by just changing one of the entities, then remember that the other entity doesn't change. It sounds like it's very complicated, it's not. Here we're going from this mixture to this one by adding water. Therefore, track dye. Here we're going from this mixture to this by adding dye. Therefore, track water. That's it. Fine. So make sure that whatever is not changing, you're anchoring around that. This question becomes very simple. Yeah.